Good afternoon, everyone. Like every year, on 6th of September, NISER observes its Foundation Day. So today, as we stand here, as we assemble here, we are here for observing our 12th Foundation Day. Before we begin, may I request the Registrar, Dr. A.K. Naik, to kindly escort our Director, Professor Panda, and the Chief Guest of the occasion, Professor Parida, to the dais. Now I request Professor Panda to kindly felicitate Chief Guest with a flower bouquet. So on behalf of the entire NISER family, let's extend a warm welcome to Professor Parida. Thank you so much. As I said, like every year, we have been observing this Foundation Day on 6th of September. It's only last year, and when continuing with last year's endurance to this year, we have been a little unfortunate to do it on a larger scale. So I would request Professor Parida not to get swayed away by the audience out here, because people are not actually on the campus, and I'm sure you would appreciate that. In this hour of crisis, we have been struggling to fight with the virus, and most of our activities, academic and otherwise, are actually being conducted online. So it may be little unfortunate not to see the seats in this auditorium occupied, but that's how it is. So let's call it the new normal. Moving forward, I'm sure many of you know the significance of 6th September, 6th September for NISER. While doing so, please ensure that you maintain the COVID guidelines. So do leave at least one seat vacant between two occupied ones. Okay, as you people move to the front rows, let me quickly take you through the memory lane. We were incubated in a small campus, in a small building rather, inside the Institute of Physics campus in from 2007 to 2015. So people who have joined directly in this campus would probably have very little idea about how life used to be and how we used to struggle for each square inch inside that campus. But then, that campus had its own charm. We were like a small, tiny family. But then our destiny would have it. In 2015, sometime during the summer vacation, we made a move. It required, as I said, a lot of endurance, lot of struggle, in fact, to cope up with the demands of shifting. As you know, the laboratories that required moving, shifting, equipments from the old campus to new one. So we have lost quite a significant amount of time in the process. However, those notwithstanding, we have managed to find our foothold in this new campus. So without me, wasting your time, let me introduce today's speaker, Professor Ajay Parida. Professor Ajay Parida was born in the year 1963 in the district Jajpur of Odisha. He went on to obtain his BSc degree from Revenue College, Cuttack, and master's degree from Utkal University. Then he went on to do his PhD from Delhi University and did quite a lot of postdoctoral research in University College of Wales in the UK, University of Naples in Italy, and International Rice Research Institute in Philippines. To his credit, he has got a plethora of awards. I would just put before you very handful ones. Notable among them is the Padma Award, Padma Shri, that was bestowed upon him in the year 2014 for his contribution in the field of agriculture, plant molecular biology, and biotechnology. As you know, that's the fourth highest civilian award that Indian government confers on any outstanding personality. That apart, and what a coincidence, we are sitting inside Samanta Chandrasekhar Pathani Samanta Auditorium, and our chief guest has received the award, Samanta Chandrasekhar Award from the government of Odisha. He also has bagged Ruchi Bharat Jyoti Samman by Ruchi Foundation Odisha, has been recognized by the National Academy of Agricultural Sciences in 2014, NASI Reliance Award for Application-Oriented Research in Biological Sciences in 2009 by the National Academy of Science India, and several other memorial and other awards have been bestowed upon him for his extraordinary contribution to the field of science and technology in general and agricultural technology and science in particular. Among recognitions, he has been an elected fellow of National Academy of Sciences, Allahabad, National Academy of Agricultural Sciences, New Delhi. He's been a member of very many international advisory boards, including those from Netherlands, from UNIDO Geneva, from CGIAR Senior Leadership Program of NARC as a participant in 2007, overseas associateship of the Department of Biotechnology to work at International Rice Research Institute, Philippines. Professor Parida has made immensely notable research contributions in the field of agriculture, plant molecular biology, and biotechnology, as I said a little while ago. And people who are working or researching in the area of biology and plant biology in particular, I'm sure his name is not unfamiliar to you. Talking of Institute of Life Sciences, where he is presently the director, he's been in fact lending his helping hand to NISER in many ways, be it research, be it academics, or be it applications. His pioneering contributions in identifying stress-tolerant genes specifically for salt and drought stress. His research has contributed to the basic understanding of the genetic architecture and species relationship in mangroves, cereals, legumes, and other cultivated crop sciences. He has supervised 25 students for their PhD degree, published more than 100 peer-reviewed publications, and traveled to more than 30 countries. Professor Parida is involved in application of science and technology for rural development and is actively involved in working with grassroots organizations and local communities in identifying the issues affecting flood and livelihood security and providing solutions based on participatory approaches. Professor Parida, prior to his current assignment as the director of Institute of Life Sciences, was serving as the executive director of MS Swaminathan Research Foundation, Chennai, from the year 2009 to 2017. Thank you so very much, Professor Parida, for agreeing to be here with such a short notice. So I don't really think we could have asked for a better speaker on this occasion. So please welcome Professor Parida for this.
Very good afternoon to all of you, and esteemed director of the NISER, Professor Panda, a close friend and very well wisher, the registrar, Mr. Naik, and my friend Vedant, who sit in so many committees of Government of Odisha, and many times we argue among ourselves whether what is right or what is wrong. And faculties of NISER, the dear students and all those who are attending the online, witnessing this particular function online. First of all, let me wish you all happy birthday for NISER. It's a great privilege. I think this reminds me, as said, that I was working with Dr. Swaminathan. Dr. Swaminathan and his wife, in sometime in 84 or 85, went to Mr. Binoba Bhave. And then they said that today is our birthday and you please bless us for our betterment and what we should do in the future. So Binoba Bhave said that it is not that what I should bless you or what I should do it. I think you should set a mark for yourself and just take a vow that your next year's performance should be much better than what you have achieved last year. So I think that speaks for volumes. I think a person like Binoba Bhave talking to Professor M. S. Swaminathan, and I think that we all should either the faculty or the director or the students, all of us, even I tell in my institute always, that please see to it that your today is better than what you did yesterday. And if you can inculcate that in mind, so I think every issue can be solved. I think you'll be achieving much higher degree. So that please aim for that whatever achievement, whatever small recognition, or whatever you have achieved during the last year in terms of number of publication, number of patents and all these things, see to it that both individually and collectively, they are much better than what you have achieved last year. So I think nothing better to celebrate your birthday next year when you see that, okay, we have progressed another 30%, whatever we have done last year. And the things are changing quite considerably. I think those who are in director position, they know that what are the difficulties we are going through. On one hand, we are all always, like for example, NISER is a basic research where the teaching has been the major focus of this. But it is not that anymore that teaching is the ultimate things. You would also look into what is the type of products you are developing, what is the type of translation you are doing. So all these things also being evaluated on a day-to-day basis. So basic fundamental question everybody, every student and every teacher need to ask, what we are doing is that I think what Gandhiji once said, that you please remember the face of the poorest person you have seen today and think about yourself that whatever your action you are taking, is it going to benefit that last person or the last mile? And if that is benefiting them, I think that should be the best contribution we'll be making. So when Dr. Panda asked me to speak here, I know that it's a very interdisciplinary subject where you have basic understanding. So what I thought I will make more of, because science education and research, I think that your institution name is defined as science education and research. So in that context, I think what we're going to focus on science, and what we could do is that it will make a difference in the societal thing. So I think in the we need to look into what science and technology is relevant and which is specific to the requirement of the people. So that is why I've chosen the science technology. All of us have been talking earlier about science and technology, but now the innovation has been added onto this. So I think all our starting from the independence, if you really look at the independence, the first speech which Sri Jawaharlal Nehru, Pandit Jawaharlal Nehru made in the first parliament, and then he repeated this particular thing in the National Science Congress, where he said that the future belongs to the science and those who make friendship with science. And that was a remarkable statement which was made by the, the first Prime Minister of the country, where he really focused that science is going to be a vital in solving many of the problems. And from that day onwards, successive governments or successive Indian policymakers has really focused on science and technology for making a change in the lives and livings of the people. And that is very evident that compare with the countries who have got independence on the same day or previous day and all these things. And if you really look into the science and technology achievements of science and technology infrastructure, we have really gone ahead of this. And what it did, I think Mrs. Or Pandit Nehru, so he initially thought that, okay, I mean, apart from building many of the institutions, like whether your IITs or your Bhava Atomic Research Center, and many of the institutions which are created, but at the same time, he talked about two things. One is the Vakranagar Dam, which was inaugurated in 1952 or 53. So that is the, what you call that. That signifies because water was so crucial, and now also water is so crucial because that was a multi-purpose uh, hydroelectrical uh, dam, which was not only giving the electricity but also was providing irrigation for the agriculture. So, and then at the same time, he has also inaugurated during the same period the Apsara so-called reactor was built in the Bhabha Atomic Research Center. So you can see the focus was food security, energy security, and your water security was the three major challenges which was taken up in 1950s. And I'm sorry to say that still now, I mean, after 75 years of our independence, we are still struggling with the same three issues, whether it is food security, water, or nutrition security, or even energy security. So, despite all our effort which has done, and during this period, we have really traveled much in terms of science and technology. The left side, you could see this was the first satellite Aryabhat which was done, and it was being transported in a cycle by some of the scientists and also a bullock cart where the satellite was taken to the launch center. From that day, if you really look at like last year, we achieved the milestone of in a single rocket, we had launched about 103 satellites in one go. So I think what we have achieved during last so many years, and all this has been possible due to science and technology intervention. And even, I mean, all of you know about the COVID, everybody is talking about the COVID, but look at the type of investment we made. And we are now proudly, you can say that India has been able to develop in a very small time frame two vaccines, which is now not only being accepted by Indian community, but it has been, I mean, a lot of global communities also making that particular effort. And no other country in the public sector, I'm talking about the public sector technology because the both Covishield and Covaxin was developed in partnership by ICMR and all these things. And there is a lot of other vaccines which are coming up in this doing this. So basically, so when we talk about science, technology, and society, there is always a link between what the science does, what the technology does, and what is the how does the society benefits. But all these three cannot operate independently because science has to get the information from the society, what is the real issues which we are facing, and then the technology has to be developed in as far as the requirement of the society. So that is where I mean it's not easy that in scientific way if you can come out with a breakthrough discovery, not always that breakthrough discoveries can be translated into technology. The technology requires a complete different set of thing, and which is not only going to be a disciplinary science, but it is going to be multidisciplinary. For example, the vaccine development, somebody may have isolated the virus, but then when it goes to the fermentation stage and then efficacy trials and all those things, that requires a whole lot of people to be involved in developing a technology. While science is single-minded, somebody inside the lab can develop a scientific solution, but to convert the science and scientific solution to technology, it requires a completely different understanding and different setting. So, and I mean, even in all branches of science, whether you talk about physics, chemistry, geology, and all these things, this has also been developing with different magnitude. For example, the formal science, which is mathematics, physics, or they look into the most of logic-based scientific things, and then it goes towards life science when you look at the more of complicated issues of cells, DNAs, and all these things. But finally, all your information, whatever you get it from the material science or biological science, it has to be applicable to the human society, where I think earth science, space science, and all of the science make into existence. So don't think that if you're looking working on biological science, that in your near future you may not require the support of the physical scientists or chemical scientists, and that is the reason you'll find the courses like biophysics, biochemistry, when all type of things added onto this. So, and this is where I mentioned that our first scientific, India's first scientific policy was defined in 1958, and then it was revised in 1983, where what you call the technology was added onto this. Earlier, it was purely science-based, but in 1983, this technology was brought into the science and technology. In 2003, it became more pronounced that science and technology has to be taken together, and then bring in investment into research and development to address various national programs. In 2013, yet another science and technology policy which came into existence by the Department of Science and Technology, where 2010 to 2020 was India has declared what we call as a decade of innovation. I think so. As our human society's need is increasing, the scientific policy and scientific solutions are also increasing. So basically, if you look at the science and technology innovation ecosystem, so it defined that to meet the challenges of faster and more inclusive growth by balancing between open source and the competitive innovation. So while there was protection of your intellectual property right, but at the same time, if it is a government supported project, the government has the right to take the technologies which are very appropriate for making it as open source innovations, because it is going to be funded, since it is going to be funded by. And the same thing happened because in Bharat Biotech's Covaxin, when the strain was given by ICMR, National Institute of Virology, so now Bharat Biotech cannot claim saying that I cannot give it to anybody else. So if the government decides, it can be given to 10 different manufacturers, and they can start manufacturing vaccines which are going to be used for the global good, not for making profit of those particular companies. So basically, when this innovation issues started coming in, so there we started looking into three aspects, whether to talk about climate change or adaptation to the climate change. These are the global problems, which is at the national level, at the local level, everywhere we are going to face it up. But these are the things which are called as interdisciplinary and or multidisciplinary areas where all scientific disciplines to come together. The second one, they talked about the weather extremes and natural disaster changing, challenging world. And the third was a affordable uh, healthcare system or the healthcare system for the country. So these are when the science and technology innovation system came into existence, what they said is that we can have independent research works will going on, but these are the national priority goals where scientific solutions need to be placed. And this is where we have to really make lot of balances in our things. Like if you are a growing economy, then you are damaging the world's environment and the energy requirements. And when the energy and everything is fine, your consumption pattern goes up, and while food availability, water, or the strain on the ecosystem goes up. And when consumption is fine, but then there is an imbalance between health and poverty. Some people are healthy and some people cannot afford to have the food. Similarly, in case of the economy, you have to really look into the globalization problems and also how to compensate with the human right issues. So if you really look at these things, so what we are talking about, what science and technology can do for India. So it can bring in social and economic changes. It can upgrade the technical skill to make them relevant and competitive, develop advanced technology and transforming the nation into a modern and industrialized society. So that is the vision which we have for, say, for example, 2035 or 2025, that is the thing. So key factors that drive the progress of the country to the measure, that is where we require the scientific knowledge and expertise. We also require innovation, and we require also technology, high technology, industrial infrastructure, and skilled workforces in the sense that all type of workforces would require. And if you go back to the scientific development, and you know that Indian science has started with zero. I mean, our major recognition for the scientific contribution of India, we have started with the discovery of zero. I think that is quite in the Aryabhat's time. But after that, we have really done very excellent in the mathematics or in physics, and any area you take, we have really. So similarly, in the around 800 BC, whatever you're talking about healthcare system, the Susruta, the world's first surgeon, which has been well documented, where so we also inherit this thing from our inheritors. And similarly, in case of the missiles, lot of innovations has taken place in the area of space technology. And in education, you can really appreciate that what we have gone from what we call classrooms to digital classrooms. But now with the COVID invented, or COVID making this particular pandemic. So in that case, the online system of education has really gone to quite substantially, although physically we are facing a lot of problems, those specifically in the age group of those who are able to go, those who are eligible for going to the school, they have not seen the school for last 2 and 3 years. And that is creating a lot of social anxiety and the development of the children further in the future generation. And similarly, in case of drug discovery from the medicinal plants, what you could see that diabetes is one of the major problem in the country. But like the public sector institutions like CSIR in Lucknow, National Botanical Research Institute, has come out with the herbal formulation for this particular BGR34 involving 4 different species, which is now making. So now the technology which has been taken from the laboratory of NBRI has now made it to, I think, during last 3 or 4 years, NBRI has earned something like more than about 40 crores rupees from this particular one technology. So there are enormous scope which is on that. Similarly, for example, come into the agricultural sector. So what has happened is that in 1950s, our food grain production, total food grain production was about 50 million metric tons. And if you really look at last year's our total food grain production, that has gone to 350 million metric tons. So during last 70 years or so, we have actually multiplied our productivity by about 5 times in food grain production. In milk production, we have gone really up to 10 times more production. Egg production has gone by almost about 50 times. Fish production has gone to about 30 times. 13 times or 15 times. And horticultural crop production has also gone almost triple during this particular period. And more than that, what we could see is that we have exported a lot of our basmati rice variety, and this is something like last year's figure is about 43,000 crores was the income to the exchequer due to the export of basmati. But imagine in the entire basmati development, the government of India has spent only about 150 crores. Starting from 1960s to now with 2 breeders or 3 breeders and a field-based work. So new bred varieties of basmati was produced with about 150 crores or less than that. And that is giving you a return of 43,000 crores a year. And if you take entire ICAR, that is Indian Council of agriculture research budget, it stands over 6,000 crores a year. And imagine one technology can transform the entire thing. I mean, ICR can take 5 years, they can run their own institutions by 1 year's earning from that. So investing in science and technology has been really tremendous importance. But at the same time, the technologies are also moving very fast. All these experiments, what you call that, the technologies which has happened in agricultural field, this all has happened because of the classical breeding methods, where you cross the two best and then develop the things. But now we are entering into the age of what you call the genomics era. And if you could see in the genomics era, look at the type of genomes which are sequenced. By the time I think when we are talking in the world, what you call world literature, there will be 3 or 4 more species will be added with the genomic information. So that is the power of technology which is happening in this particular thing. And so the best thing is that how do we, all the new researchers or the new faculties, how do you take the advantage of this new developments which is taking place? And that is a call for this. But our major challenge is that what we do in the research laboratories that do not get really translated or transformed into the farmer's field. For example, I'll just take a example of rice. If you go to CRRI Cuttack, where they're working on rice research, so they're elite farmers or their own experimental field with all controlled water, irrigation, and all these things. They can tell you that we have developed a variety which can produce 9 tons per hectare. But when it goes to the progressive farmers field, when it goes to from the experimental field to another well-to-do farmers field, the productivity immediately comes down from 9 tons to over 6 tons per hectare. But unfortunately, what happens that when it goes to the farmer's field, what happens is that it just produces over 2.8 to 3 tons per hectare. So what we are doing in the research laboratory and what is happening in the ground level, there is a huge difference between those things. And if we imagine if a farmer can produce 9 tons per hectare, we do not require all the lands to be cultivated with rice crop. So that I mean, you can say, I think rice is another good example of who consumes a lot of water. So imagine if we can diversify 50% of crop cultivation from rice to any other crops, we'll be saving a lot of water which can be utilized for this thing. And you will be surprised with the statistics, like 70% of the water available in India or available in elsewhere, anywhere in the world, is utilized for the agriculture. I mean, statistics can say that to produce 1 kilo of rice, we use 1.5 cubic meter of water. I mean, we're talking about starting from the cultivation till the last, if you take. So these are all going to, so on one hand, if you start producing more food, that also gives the pressure onto other things. So as I mentioned to you that a lot of advancements has been made. As of today, like you could see that about 80 biotech drugs, vaccine, diagnostics, with more than 400 biotechnology developed medicines are available, targeting over 200 diseases. So I think what is happening is that because of these developments in India, you could, I mean, there is a new term which has come that India is becoming the capital for medical tourism, because our cost of medical facilities is much lower compared to any other countries in US or Europe and all. So what you find is that all the Southeast Asia or the Gulf countries, they are primarily coming for the medical treatments to India because it is affordable and low cost effective. So with all these things, but then what is the problem? That we have done so much of progress in our development, but then I think we are going to face a serious challenge of the food, which is going to be our demand by 2030 is going to be more by 50%. We'll be requiring 50% more food in another 10 years' time. We would be requiring about 30% of water increasing demand, or in water demand will be about 30%, and we will be requiring something like 50% of energy requirements as the societies are going to go out to it. So This is all happening because of the increasing population, then increasing level of urbanization, and finally the our concern about alleviating poverty and malnutrition. But you have to also, in the context of India, if you really look at it, India is a, I think we have two divides. I mean, we have two great divides. One is, I think we have roughly about, I mean, we have something like now 1,200 million population. But if you really look at what you classify them, what happened, there are a good group of people, that is 300 million Indians, which are really resource surplus and they're well connected. I mean, connected means they're good living habit. But at the same time, you have something about 300 million Indians are absolutely poor. So, and there are again middle class group which are called as climate sensitive. That constitute about 400 million people who are living on margin. I think anytime they can come to this side or that side. So they are fluctuating. But what divides these two groups? I think our income divide, then the digital divide, as well as the knowledge divide. I think these are the three major factors which are dividing them. But if you really look at the hunger and poverty, we are all talking about that it is intergenerational. So it is our duty now to ensure that the more than hunger, but I think the hidden hunger which we are talking about, that is a malnutrition. Like if a mother is say anemic, the child which is born to that particular mother is going to be anemic. There is absolutely no doubt that they will not be anemic. So what is happening, that if a child is born as anemic, we are compromising the entire life cycle of that particular child. So they will not have good growth, there no good mental development. So I think malnutrition or hidden hunger, which we are talking about, is going to be a major concern in the coming days. The next is the what you call the major challenge of the impact of climate change. There are so many what you call IPCC. There are so many reports which are coming, which shows that in next few years we'll have something like 4 degree of climate changes, which is going to increase the vulnerability both in terms of the extreme climatic events. Not only that, I think the disease burden or the disease things are also going to play a major role. So I think as scientists, all of us need to really start thinking about developing programs or issues which can sort it out. The third major concern which we are facing is the food wastage. I mean, look at the type of food waste or what we are getting. Like, for example, 30% of the cereals we lose, 45% of the fruits and vegetables are lost, and 30% of the fish or 20% of the meat resources are gone. And if you can tackle the addressing about on an average, it will be about 30% of the food waste. And the previous slide which I showed you is the 30% people are poor. If you can just balance this out, if this food does not go waste, at least those people who are not having a regular food of their own, they can survive. So that's not going to be a challenge. And I don't think this is a very difficult job to do, but I think it requires a little bit of change in the mindset. So so the question is that, I mean, we have issues, we have scientific knowledge, but the question is that where do the idea come from? I think we are all, I should not, I also include myself. I think we have been in our scientific endeavor. Indians has become basically a follower. If somebody has sequenced this species A, we will wake up there, see that paper and say that tomorrow we'll sequence the species B. Somebody has worked on this particular disease. Okay, so when you start asking, sometimes we sit in the review committee and they will say, we said, why you want to work on this? So this has already been worked out by somebody in US. They'll say, no, they have worked in US, but not in our type of pathogen or type of pesticides or type of disease we are working on. So we want to look into this. So the question is that ideas, I think we need to all try to find out. As India, as a traditional country, we have tremendous history of contributing to the civilization. So the question is that where ideas come from. I think the best thing is that look around your surroundings, you will find a lot of ideas. You could see some of these photographs. Look at, I think many of you are students, you could see in the top right side photo. So you can also use your, what do you call, iron box for making your tea in your room. I think those are the type of ideas. But more than that, I think I'll just show you that these are the innovations which are talking. I think many of you will be aware about the honeybee network of Dr. Anil Gupta of Indian Institute of Management in Ahmedabad. He has really documented a lot of innovations which has happened at the grassroots level. For example, the left one is that it's in Sundarban area, where this is basically a cycle, but which can also float in the water because there are, depending on the local conditions. The right side photograph you could see it's from Kerala. You know that with the labor cost is going up and nobody is not available to climb the coconut tree. So some type of a what do you call, a automated machine which is so that somebody can climb on this particular thing. So now even ladies can climb up the coconut tree and start fetching them and start collecting the coconut. And also if you are genius, so you can use your laptop and do the saving in your room. So basically, since all of you are this thing, so what we are looking at, so how do you prioritize what science can do? So basically, we need to ask a question and then do a background, what you call, research, whether something has been done, or am I going to do something which is different? Then you follow, the frame a hypothesis. You can see that what exactly you are trying to do. Then test your hypothesis and to do with the experiments, and then analyze the results and accept that. That is what you can establish the hypothesis. But at the same time, you have to be, you have to also keeping in mind of a inquisitive scientist that you also need to look at the scientific integrity, because that is very basic thing. That scientific integrity is not that somebody has already done this. I will not, if I don't disclose, nobody will be able to know about it. So I think that is what scientific integrity also is a major thing. The reproducible result is also very important. Otherwise, you do some experiment and one result you get which is very good and which is not reproducible, then you will get a more bad name rather than getting credit out of it. Then I think all these things are very required, and the collaboration is also key for succeeding in a scientific discipline. Earlier, we were all talking about having our own comfort zones to look at. So the question is that if you really look into the innovation system, the idea can come, but innovation is only 1% of what is your total idea. Everybody is talking about innovation, but I think you have a bright idea, but that idea to convert into a product or to take it forward, it really requires a lot of work. And as I told you, that the boundaries between different disciplines has also completely disappeared. Whether you are working in systems biology or molecular biology or bioinformatics or evolution, traditional medicine, anything. So there is going to be a complete package that you cannot be completely remaining in the isolation. But at the same time, as I mentioned, that the what do you call, the type of issues or the type of challenges every country faces, it is completely different. As a country, like even within the country, what a problem of Punjab farmers are facing and what the Orissa farmers are facing, that issues are completely different. It is not that agriculture means you can browse in one particular thing. For example, look at the type of causes of the death in the global scenario as well as in the developing countries. In the developed countries, the major concentration of or major cause of the death is basically heart attack, lung disease, uh, stroke, bronchitis, and these are the type of diseases which you get. But look at the what do you call in the developing countries, underweight of the people. That is where malnourishment comes into picture. Unsafe water, sanitation, indoor smokes or solid fuel, zinc deficiency, iron deficiency, and some type of high blood sugar. These are the major issues that come. So what we need to do is that the type of different research and innovation would require different type of things. So I think as you all of us are aspiring to be great scientists, so I think the four basic principles one need to look at it. Believe in yourself, question the traditional assumptions, what you know, expand your problem solving styles, and then practice thinking in new way. So I think you don't have to think different things at one particular time, but you have to start thinking differently so that you can achieve or you can address some of the issues. So as I said that I mean, I'll just give you an example of the COVID again because that's a very topical thing. When the COVID advertisement came for various scientific groups to submit research proposals by the Department of Biotechnology and as well as the BIRAC, that is Biotech Industry Research Application thing. You will not imagine this is the 10% of the project which are supported. We really got flooded with something about 1,000 applications for research grant from various quarters, from small universities, from big universities, as if everybody started saying that we have a solution for COVID. You give us the project for 1 year, we will develop the whether drugs or simulation, everything can be done with our money. But with a great difficulty, we have been liberal in this particular thing. So we submitted, we supported around 79 industry academia collaboration, and there were 41 independent research project was given. But at the same time, with all the lockdown and all, but people are really committed. And as I showed in the previous slide or the earlier slides, you could see that India is now in the verge of developing about 9 to 10 vaccines against COVID, and that is possible in 1 year time. But the problem, what happens is that when you have to vaccine, okay, we tried the efficacy and we did that, but for making a vaccine, what you call to market it, you require some type of adjuvants, and adjuvant, the best adjuvant is the alum. And can you believe alums are not available in United States or India? All alums are available in China. So how to get the adjuvants from China? I think on one side, the government of India has also said that we will not procure Chinese good. So then I think some via media, so from Singapore it is coming, and that is the primary reason why our vaccine production has really slowed down. Had we been slightly more aggressive on procuring those adjuvants, or we could have discovered some other adjuvant in other than the alternative adjuvant, then we could have gone with, I think, millions of or crores of doses of production. I think that is becoming a limiting factor. So technology is great, but if your other components are not there, you cannot achieve whatever the target you are going to achieve. So similarly, like everybody started shouting at the Department of Biotechnology, saying that a country like United Kingdom has submitted something like 1 lakh, something like 1 million sequence information to the global database for COVID. And as a country, India, how much they have done? And our target was to do 5% of the sequencing for every positive cases. But despite all these things, because what happens, we do have technologies, we do have infrastructure. Again, as I said that about the adjuvant, here what happened that when you started doing sequencing, you have the Illumina machine with you, but the consumable has to come from US or Germany. You do not have the kits, so how do you produce it? So, but at the same time, if you could really look at this particular graph, it's really within 1 month time we could set up this particular network where we had something like 339 sites from where the samples will be collected. We had about 28 laboratories where the sequencing can be done. We are tied up with about 16 hospitals, 16 hospital network. and also 10 cities for doing the surveillance. And more than that, what we also did is that we roped in the private sector onto this and also state level onto that. And all this could be achieved in a month's time to put it into that. I'm very happy that from April, May, and June, we have so far sequenced something about 80,000 plus genome sequences throughout the country. And that is where you could understand the Delta or Delta Plus or new variants which has been detected. So we are very proactive. The detection of Delta Plus was done within 4 days of appearance of the Delta Plus variant in the country. So we have capability now that we can really find out, not only I'm talking about the global variants, but if there are some mutant which is happening in India also, we'll be able to find out in the least given number of time period. So now our current focus is that we're looking into those younger kids below 18 years. I think above 18 years are mostly vaccinated, but below 18 years now the trend of genomic what you call mutation, the infection is rising. So that is the reason we're focusing on the children below the 18 years group of 18 so that those sequencing can be done. So since I come from ILS, I can say you that although during this lockdown period, we really focused on doing a lot of work. For example, we have been a testing center where we have roughly tested something like 3 lakh samples from government of Odisha. We have also carried out more than, as of today, we have carried out over 6,000 samples because this 300 does not involve the INSACOG things. More than that, we have established about 17 virus cultures, both including the original virus, that Wuhan virus, as well as all the mutant strains. So anybody who has a vaccine or a drug, they can be tested at the ILS. And we have also done the immunoprofiling studies. We are now developing animal challenge studies for vaccine development. We also have a what do you call the screening for the drug libraries or the drug compounds. And as I said, that we have been also done. We have done also we have been a part of the regional center for the genome surveillance. Given that, I think this is one which we said that on one hand, we had a real great challenge in the sense that all the offices, establishments are closed during the COVID time. But despite that, we could really achieve in a very short period of time all these things. So thanks to all my effort, my colleagues who has done it. So this is what I said. This is a very immediate, what you call, a problem which initiated 2 years back, and that is where the scientific community has done. But at the same time, there are other major programs which ILS is carrying out. For example, you know, the India is a country of diversity. A whole lot of, I think we have something like 4,500 well-defined different populations. The person which is in Eastern India, South India, West India, they are completely different genetically. But as of today, I don't think that India has been able to map the diversity which are present in the country. So a very massive program under the Genome India where we're charting the genomic diversity of India. So with involving something about 18 or 19 research institutions where somewhere around from each state we are conducting whole genome sequencing of about 3,000 different tribes or different populations belonging to different tribes. So this is what we are. This is again a research program which is going to be taking up to looking into the what type of diversity present, whether they are ethnically, what is the evolutionary phases which has gone. But more than that, this is at a what I said, this is at a national level. But at the same time, we started also looking into what we could do in ILS. For example, we have a major program undertaking. We're undertaking a major program on what we call tribal health and nutrition, where what we are looking at in Orissa, as you know, that we have something about 1 million, 10 million people who are tribals, and there are 62 notified or gazette notified tribes are there. And this is for the first time we are taking a very omics based approach or omics based study where we are looking into the genomics profiling, immunoprofiling, the nutrition profile, as well as their microbiome profile to really understand what are the type of diversity exist among them. And do we like what the question we're asking in this particular thing is that is it that some particular tribe is susceptible to a disease or resistant to that particular disease? So can we identify hotspots or hot populations where there are diversity is there so that so that you can really give that the policy dimensions onto this particular thing. So based on this, we have selected four districts of Odisha, that is Nabarangpur, Malkangiri, Sundargarh, and Mayurbhanj. Look at the type of stunting percentage is 45% of the population are stunted. That means they have vitamin A deficiency. They are about 32% of 50, 32% population are wasted, and anemia about 72%, which is iron deficiency, both among the women and all these. So these are the prevalent. So what we hope is that these are the type of research work which is required to be taken up at the local level which can serve. So I think the technology vision I have already mentioned, and that is where we need to what the technology vision says, that we have to also take transformational technology like materials and manufacturing, as also give more focus on the ICT related issue. So with all these things, I think India is now a country of destination. Everybody is looking into India for whether basic scientific. I think all of you know that we are IT supplier of the largest human resources for the IT industry. But we're now looking at whether a clinically relevant framework can be developed for India. And so, so what is the advantage we have? The excellent research network of the research laboratories, including NISER. We have rich biological resources and diversity, both in terms of species diversity, biological diversity, and also human diversity. So I think human diversity is actually what we're talking about. India is a living laboratory which has all type of diversity present in this particular thing. So you will get all type of geographical regions where the inhabitants are more. And extensive clinical trial opportunities. I think many of you might be knowing that the big pharma industries which are boasting, saying that we are a global company, but most of their activities are related to the clinical trials which is being conducted on behalf of the other countries. I think that is fair, but I think we need to do that. So I think what all of us are talking about, that I is the key word, whether it is innovations, incentives, or investments, or institutional infrastructure, it all going to play a major role in that. And as I mentioned, that a lot of work has been done. I think you know that there was promises, I mean, what you call Tata Nano, which was introduced, saying that 1 lakh rupees per car, or Jaipur food, which is very affordable. I think why I'm showing this particular three pictures is that if you compare this with the global market, it must be about 5 or 6 times more than what we are giving in India. So whether it is Jaipur food or even for the hepatitis B vaccine, and can you imagine 60% of the hepatitis B vaccine marketed is from India's pharmaceutical industries. So all entire Africa or all developing countries or developed countries. So I think that's what has happened is that during this process, a lot of innovation has taken place. A lot of companies has started from what you call the startups to a big business. And you'll be surprised, most of your favorite brands will be in this, who started with a zero and went on to make billions of dollars. And so that is what everybody is talking about. If you have your innovations in place, your right thinking in place, you can really make a big market. I mean, just imagine Bharat Matrimony, who thought that it could be $1 billion business? I mean, so these are the things which also try with looking into the innovations. But at the same time, you all have to be patient a little bit. It's not that overnight you can convert your Zomato from 0 to 100 millions or 200 millions. So as I mentioned in the beginning stage, like idea generation takes a lot of time. Then to make that into a product at the seed stage, I think we're talking about something like acceleration stage. We're all talking about at least 4 to 5 years of developmental stage to convert really into a business opportunity. So there are a lot of scopes are there. And this slide I have taken it from the BIRAC biotechnology industry relevant workshop. So so if you really look at where are the type of technologies we are coming ahead, it is basically in healthcare or plant disease management or promoting the drug discovery or drug library areas, or even which are simulations, drug simulation models, and also quite a lot of other things. So given by this, again, as I said, that at Institute of Life Science, we have established a ILS business incubator. And this was done during the COVID time. So unfortunately, we could not attract many of the things. But despite that, I'm happy to say that as of today, we have over 12 startups which are established at the ILS incubator. And we recently just had a interview for the new cohort, and another eight startups will be joining from them. And if you really look at their profiles, I'm not going to detail out any of the profile, but if you look at the ThinkGenix, a company who are working on the fish to waste products and making them as fertilizers and plant growth promoters at that level. And that particular company was started by uh, two IIT graduates, 7 IIT graduates from Bhubaneswar. They have now started a company 3 years back, and I think that's going to make a complete change in the thing. So looking at the enthusiasm of those two people and the type of marketing skill they have, so I think that could be possible. So what I would like to say is that in the coming days, the data is going to play a major role. The big data, that is where the all type of revolution is going to take place, and that is where the big data is also going to drive what happens in a future farming system, whether you have robotics based or everything is going to be automated. So the question of that, everybody is going to ask this question that if you ask the farmers, basically we have this type of thing: a lawyer's son always will be a lawyer, a doctor's son will be a lawyer. But if you ask a farmer, do you expect a farmer's son has to also farmer? So many people, I think, attracting and retaining the youth in agriculture is major challenge. So somebody was mentioning to me that why a tractor which is used for plowing the field cannot be air conditioned. So maybe that's an innovative idea. I think so because you have not put it as air conditioning system. Nobody, if educated person who has done a master's or something, they don't want to plow a tractor in the field. But who knows that if you can just, and it is not impossible. It can be done if a small cabin can be air conditioned so that people find comfort to do that. So there are a lot of changes in the innovation. Or for example, if any of you can read, just go to the Google search that IT industry sector who are now leaving the job and coming to the entrepreneurship. And what you will find is that most of them are coming to the agriculture entrepreneurship. Either they're buying some field land and they're doing all automated farming system, or they're looking into the input things like making a biofertilizer or biopesticides, or the particular output level where they can grade it and then have a better marketing system using their knowledge which they have gotten from the IT sector. So there are new ways where things has to be taken up. So basically what we are talking about, I think all of you also need to look into these paradox of our time. There is knowledge divide. Despite spectacular advances in science and technology, unprecedented economic progress and improvement in the quality of life is affected. There are growing inequalities because of the knowledge divide, and this inequality is leading to what you call a troubled water or troubled world. I think that is lack of knowledge or misinformation or wrong information is also driving a lot of social unrest and social peacefulness. So that all of you are aware about it. We don't have to go into that. But at the same time, you're depleting resources with more of consumption or the type of consumption we have. So we are also leading a stressed planet. So I think collectively and individually, all of us has a responsibility to save our family, save our planet for what we call a sustainable development system. And what is sustainable development? And all of you might be aware of this the definition that using resources and leaving it enough for the next generation. So that is called the sustainable development. So as Gandhiji said that the world has enough for everybody's need, not for everybody's greed. I think that need to be kept in the mind. The second important point is that we also need to focus mostly on the women. How do we bring in more participation, more equality among the men and women? So I think our focus, you don't need to look at it, this picture that all the women has to be working in the agricultural field. I think women empowerment is going to be crucial in the coming days if you want to achieve a sustainable development framework. And there is no way why we cannot do it in India. We have a huge knowledge network system, something like that. We have 6 lakh recognized primary schools. We have 2 lakhs, more than 2 lakhs upper primary school. We have 8,737 college of general education, something like 2,400 professional institutions, and then 272 Institute of National Importance, including NISER, ILS, and all these things. So if we have this much of base, I'm sure we can do it, and we have to do it. And more than that, I think if I will take you back to this quote of Munshi Premchand, when he said that to be successful in life, what you need is education, not literacy and degree. I think you will need to delink your degrees from the education. Not getting a MSc degree or PhD degree is not education. Education is beyond that, what you call achieving your formal education system, and to be humble is the thing. And then I take it to the words of our late president or people's president, who said that be remembered, be unique, and be great. I think that should be the philosophy. And as I told you for last so many minutes, I think our problem is this. Our challenge is to address human-induced challenges. I think, do you imagine, can a country of 75 years after independence afford to do a train journey like this for people? And all these things are all created by us. Either we did not estimate how so many people came in one particular time. And this, if I go back, the photo was taken in Patna railway station. And this was the students who are coming back after giving or going back to their home after giving the entrance examination for a engineering degree or something. So when online classes are possible, online educations are possible, why you have to call so many people? And then I think that the basic point is that if we do not manage our resources, manage our technology, and I think this is where we have to find a solution. There are problems of plenty, and we have the competence, we have the zeal and the voices, and we can do it. And who best than the institution of your eminence like NISER? The people can be educated, or people can be motivated to take up some activities which can address to the growing social inequalities and growing challenges in the country. Thank you very much for your kind attention.
Thank you so much. I request Professor Panda and Dr. Naik to please come down to the stairs. Thank you, Professor Parida once again, and it just took us back to quite a lot of back by quite a lot of years. And thank you for invoking quite a number of interesting ideas, which made many of us believe that, contrary to the popular narrative, that there is no one size that fits all. And to reinforce this, I'm sure we all will applaud Professor Parida's contribution to developing location-specific crop varieties to address the adverse impacts of climate change, which goes on to supplement what exactly he narrated a while ago, that our problems are unique problems. So let's not look for a one-size-fits-all formula, rather than looking for context-specific solutions to our unique problems. That also kind of makes us wonder. I would really. I'm sorry, I'm just elongating the proceeding by 60 seconds, if not more. Invoking people like Austrian-born philosopher Paul Feyerabend, who once wondered why there is something called scientific method. So he went on to write the book Against Method. I mean, I should not dare talking about against method standing in front of you inside an institute which is for science, fundamental science, and takes pride over doing research. However, I would like to invoke Paul Feyerabend primarily because he's the one who went to the rooftop and shouted, "Why are you restricting me as in a representative of the scientific community, to something called scientific method? Why can't we have something called epistemological anarchy? I mean, it's like the classic battle between Nikola Tesla and Thomas Edison for the battle of currents. You can't certainly have the one way of doing things. So I mean, I'm sorry. I mean, it just took me back to those days of early 20th century when people like Paul Feyerabend, people like Karl Popper, who went on to say that a good science has to be falsifiable. If it cannot be falsifiable, it's not good science. And he gave rise to a kind of a dilemma, which again another Austrian philosopher came down to his rescue, saying that okay, there is something called paradigm shift. We might actually eventually run out of hypothesis, but knowledge, the spectrum of knowledge is so wide and so huge that you would always have something to fall back on. So taking a cue from Professor Parida's invocation of the conversation between Vinoba Bhabhe and Dr. Swaminathan, I'm sure he said, if you're adding one more age to yourself, you should be wiser than before. I'm sure after listening to him for 1 hour, I'm sure we all are wiser than before. So I would request Professor Parida to bear with us for some more time, because on this occasion we actually award our academic performers to encourage academic excellence and healthy competition among our students. I know most of our students are not here. They are either logged in from their devices, but we would announce those awards, and if anyone is there, please join in to receive the awards. So for this year, the semester toppers for 2020-2021 odd semester is Monu Kumar Chobe, first year batch 2020, with a CGPA of 9.73. Monu, if you're around. No. The third semester batch 2019 topper is Pranay Mohanty with a CGPA of 9.75. Okay, it's not here. We take a note of their achievements. Batch 18 odd semester topper is Ace Gautameshwar with again a CGPA of 9.75. No. 7th semester topper of batch 2017 is Ashmita Rani Asmi. Yeah, please join. With a perfect 10. So we have actually, this includes cash prizes. However, this year the cash awards have been transferred to their accounts, but we will felicitate them with a certificate. I request Professor Parida to kindly do the honors. A round of applause, please. Come on, can't be so miser. Then subjects. There are subject toppers for each school. Asmita, hang around. You have quite a number of. No, please be around to collect. School of Physical Sciences, Ajay Krishna A with a SGPA of 9.08. School of Chemical Sciences, Pranay Mohanty with 9.75. School of Mathematical Sciences, Soham Samanta with a CGPA of 9.58. Biological Sciences, Monali Banerjee with a CGPA of 9.17. For the 5th semester, batch 18, School of Physical Sciences, S. Bhubaneswar, 9.75. For School of Chemical Sciences, there is a tie between Aditya Pal and Nitha Nathan with an identical CGPA of 9.67. Okay, we take a note with appreciation. For School of Mathematical Sciences, it's Apratim Chaudhary with 8.83 and Ashwin Kuteri with 8.83. Staying with batch 2018, School of Biological Sciences, it is Priyabrata Biswas with 9.83 CGPA. Moving on to batch 2017, for School of Physical Sciences, it's Chandranathan A with a CGPA of 9.67. For School of Chemical Sciences, it's Asmita Rani Asmi with a perfect 10. Batch 17. Batch 17. Then for School of Mathematical Sciences, it's Achishman Bhattacharya with a CGPA of 9.50. Sorry, SGPA of 9.50 for the semester. Staying with batch 2017 for School of Biological Sciences, it's a two-way tie between Akshita B. Gopal and Manisha Sahu, both with 9.5 SGPA. And for the 2020-2021 odd semester, the overall performance, and on the basis of overall performance, the topper is Aditya Pal with a CGPA of 9.75. Aditya Pal is not around. Moving on to the event semester for 2020, which was recently concluded. The overall topper for second semester batch 2020 is Vaishnav Manoj with an SGPA of 9.30. For the fourth semester batch 2019, it's Proshnodip Sadhu Khan with an SGPA of 9.58. For batch 18, sixth semester, it's Aniruddha Seal with a SGPA of 9.67. For the eighth semester, It's Anurag Kumar, Asmita Rani Asmi, Shivam Mahapatra, and Smriti Medha Parida. There's a four-way tie. A huge round of applause, please, for this 10 pointers. So all these four people have perfect 10. Yeah. Asmita Rani. Yeah, four of them. Yeah. So it's Asmita Rani Asmi, Anurag Kumar, Shivam Mahapatra, and Smriti Medha Parida. All of them have secured 10 points out of a possible 10, in fact. Smriti Medha Parida. You guys be around. You have some more to collect. Huh? Be in the front rows. Moving on to the subject toppers for each school for the event semester of 2020 and 2021 academic session. Starting with the fourth semester, that is batch 2019, School of Biological Sciences, it's Sweta Sasindran, with an SGPA of 9.42. School of Chemical Sciences, there is a tie between Anusmita Raut and Yashaswini Gupta with an SGPA of 9.42 again. For School of Mathematical Sciences, it's Prashnodip Sadhu Khan with an SGPA of 9.58. For School of Physical Sciences, it's Piyush Ranjan Padi with an SGPA of 9.25. Moving on to the sixth semester for batch 2018, the subject toppers of various schools are like this. School of Biological Sciences, it's Ashish Kumar Mishra this with an SGPA of 9.50. For Chemical Sciences, it's Aniruddha Seal with an SGPA of 9.67. School of Mathematical Sciences, it's Apratim Chaudhary with an SGPA of 9.50. The School of Physical Sciences, it's Fida Salim and Pradyot Pritam Sahu with an identical SGPA of 9.17. Okay, since now if you are around, be with appreciation, take a note of your academic performances. Moving on to batch 2017 for School of Biological Sciences, it's Tanya Patnaik. I saw Tanya with an SGPA of 9.80. Tanya. And for the School of Chemical Sciences, let's please welcome those four back. Anurag Kumar, Asmita Rani Asmi, Shivam Mahapatra, and Smriti Medha Parida. Four of them have secured a perfect 10 in the event semester of 2020 and 2021 academic year. Integrated PhD. Then for the School of Mathematical Sciences, we have Archisman Bhattacharya. With an SGPA of 9.67. And for the School of Physical Sciences, it's Pranith Nandan. With an SGPA of 9.67. And for the overall topper for this semester, even semester of 2020 and 2021 academic session, it's Suritra Bandopadhyay with a CGPA of 9.68. Physics. Sorry, chemistry. Now we have two more. For the MSc portion of the integrated MSc PhD program, it's Miss Ritvika Majumdar for the third semester, and it's Mr. Ivan Datta for the fourth semester. Okay. Since they're not around, we just take note of all this. Thank you so very much. So with this, we formally conclude the award ceremony. Now I request Professor Sudhakar Panda to kindly felicitate our guest on the occasion with a small memento as a token of gratification from the entire NISER family. Yeah, that was involved. So with this, we formally conclude this Foundation Day lecture. And thank you so very much, every one of you who made this occasion possible. I mean, I would not really like to name anyone. So thank you so very much. Guys in the audience, please join outside for a small low tea. The director's office.